the first thing we need to do when we're looking at these applications is look at some vocabulary. And the main ones in here are angle of depression and angle of elevation. So there's a diagram to kind of help you understand what those are. An angle of depression is if you're looking down at something, it's the angle made, so if you're in this airplane looking down at that barge or whatever it is, it's the angle between if you look straight out horizontally and if you look down, the angle that it makes. That's called an angle of depression. And then the angle of elevation is the opposite. So if you're on the barge and you're looking up, it's the angle made between your line of sight looking up and the horizontal. The most important thing to remember is that both of these are always measured from this imaginary horizontal line. So whenever you're looking at an angle of elevation or an angle of depression, you're always measuring from a horizontal line. The question here has an angle of elevation in it, so let's look at the question. It says, an observer sitting on a dock watching a float plane in Vancouver Harbor. At a certain time, the plane is 300 meters above the water and 430 meters from the observer. Determine the angle of elevation of the plane measured from the observer to the nearest degree. So this is just a basic trigonometry question like we've been doing, except that it doesn't just give you the numbers on a diagram or tell you the numbers and you put them on a diagram. You have to kind of figure out what's happening. So we'll draw a little picture of it. So we have the dock here and the water, and there's a person sitting there, and there's this airplane up above. The person is looking up at the airplane, watching the airplane, right? And it says that the airplane is 300 meters above the water. So this is 300 meters. And do you see your right triangle there already? Here's the right triangle. It also says that the airplane is 430 meters from the observer. Where would you put that on the diagram?
The hypotenuse.
The hypotenuse, I think, yeah. That's the actual distance from the observer to the airplane. And then it's asking for the angle of elevation. Well, this down here is 90 degrees. So we have two choices for the angle of elevation. Are we looking at this angle down here or this one up here?
Down there.
Down here?
Yeah.
This one? Right. Angle of elevation is when you're looking up at something and it's measured from the horizontal. So the water is the horizontal, and this hypotenuse is the line of sight to the airplane. So we're just trying to find this angle. I'll call it theta. Now it's just a basic question like we've been doing. Once you have the diagram, there's no more worrying about any of the information in the question. Just find the angle. So we have this side, which is the opposite, and we have the hypotenuse, which tells us to use sine. So we'll do sine of theta is opposite, which is 300, over hypotenuse, which is 430. So we're just going to, on the calculator, do inverse sine of 300 over 430. That's what theta equals. So when I do put that in the calculator, I come up with an angle of 44 degrees. I just rounded it. Oh yeah, it says to the nearest degree. So the nearest degree is 44 degrees. The question says, from a radar station, the angle of elevation of an approaching airplane is 32.5 degrees. So this, in this diagram that Jefferson drew for us, this is the radar station down here, and up here is where you have the airplane. And you're looking up at it, so that angle measured from the horizontal is 32 degrees, 32.5 degrees. Let's stick the 0.5 in there, 32.5 degrees. And then the horizontal distance between the plane and the radar station is 35.6. And it asks how far is the plane from the radar station to the nearest tenth of a kilometer. So that's the hypotenuse here is what you're trying to find. So if we have an angle here, we're trying to find the hypotenuse, and we know the adjacent. Which ratio will we use? Cosine, right. So we'll go cosine, well, cosine is adjacent over hypotenuse. So cosine of 32.5 is equal to 42 is your answer? 35.6 over hypotenuse. So you have to divide to get your answer, right? You're going to do 35.6 divided by cosine of 32.5. So when you put that into your calculator, you get the answer of 42.2 kilometers. That's to the nearest tenth.